Hello and welcome to another one. Today we're going to be talking about for loops. For loops are a very useful concept in looping in general, which just lets you execute a section of code over some amount or something. In here they have a list of words and then they'll print the word and the length of the word. And that's what the for loop's for. For loops in other languages define a comparison. So you do for you'll have a variable, then a condition, and then a increment. Or an update, they'll call it. This is how a for loop looks in C. You'll define a variable that is used in a conditional, and then you'll update that variable until this condition is true. And in this block, you'll do some statements, like how they do here. They just print. But for Python, it works a little differently. For loops in Python, they say for your variable, you'll call it whatever. I'll call it var. For var and here they use range, and I'm going to use range now just to show you how to iterate a certain amount of times. And that's all the range function does. So range will let you do something up to but not including that thing, and this has to be a number. So if I want to say for variable in range up to but not including, it stops before, because you can think of it as that conditional statement. It says while it's less than 10. That's how this works. It'll do, and you can do some more things in range, like defining a starting point, but it defaults to 0. So for var in range 10, you want to say print var. All this will do is print out whatever number, and again you hit enter twice and you see you get the numbers 0 to 9. And like I said before, you can define a starting position. So if you want to start at 4, so starting at 4, this is like assigning var to 4 and then printing var until it gets to 10, updating it by 1. And you can again do a third argument here that defines a step, so I'll do that next. Did I do something wrong? Oh, I didn't tell it to do anything. That's what I did. I didn't tell it to do anything. Print var. There. So from 4 up to 9, and then you can define the step as well, which is the update condition for var. Say you want it to update by 2. So this should print all the even numbers from 4 up to but not including 10. Yeah, 4, 6, 8. So you can see how that's very similar to the for loop I gave you in the beginning. So there's a variable, a condition, and then an update. And that's almost exactly how this looks. It's except you define your variable here. There's a difference between you declare your variable, and then this defines it. Otherwise, it's defined to 0 by default. There's a difference between declaration and definition. It's like saying, I have a variable x, and that's it. X is not defined. I didn't define it, I just declared it. But in Python, you don't have, it doesn't do variables that aren't defined. So you don't define an x, or you don't declare some variable and then use it somewhere else without it already having a value. So if I said x equals 0, x by itself is the declaration, and x equals 0 this equals 0, is its definition. So x is defined to be 0. That's how you can read this. And you can also do for loops on things that are iterable. So that means they have an index or something. So if I had a string, so we say, let's say my string equals, this is a string. So that's my string. So I can do this, I can do an iteration over a string, and I've shown that strings are really just arrays of characters. So likewise, you can just do iteration over an array. So if my array is equal to, say, 3.4, 49, 2.3, and 88. So this is my array of numbers. So I can say for, and really this part, this is just your variable. So you can call it whatever you want inside the for loop. So var can be anything you want. So most people that do for loops are calling it I or something, they don't really care. But if you want it to be legible, so you can think about it, well, what is each thing inside of this thing I'm iterating over? So in my string, it is a character. So we can say char. For char in my string, I want to print my char. And this is every character inside of my string. This is a string, period. You can do the same thing for array or lists. You can do the same thing for lists, except I would call this number. For number in my array, I want to print my number. And here's every number. You can also do fancier things like doing things to the number. So if I wanted to say, I want to print every number, but I want it to be an integer. So I have two decimal numbers here, 3.4 and 2.3. I want those to be whole numbers. I don't want them to be floating numbers. I want them to be integers. So I can cast the number to an int and print it out like this. So you can see that it ditched the mantissa, which is the numbers after the decimal. It rounded them off. It always rounds down. It never doesn't round up. If you wanted to round up, you'd have to do some you have to use the math library, and maybe we'll get to talking about libraries sometime soon. How to import a library and use functions and classes that someone else has written, and you can put those in your program without having to write them yourself. They just tell you how they work. That's what this range is. Range is actually a built-in function. Right here you can see built-in function, and actually, like things like print are built-in functions. For these keywords are actually functions and how they work. But maybe we'll get to that later. And here you get to see, you can also do negative stepping. This is a start point, this is the end point. Up to but not including, stepping by 30. What else do they do? Array over indices. Oh, this one talks about arrays. Oh, and this one says to the length of. So you can also, this evaluates to a number. So since it evaluates to a number, you can pass it into range. This will say, well, for I in the range of the length of A, which you don't really need to do this. If you just passed A, it would work. and they show you that up here, I believe. Right here. So you don't have to pass the length of this. I guess just to show you that you can do this. If you just pass A, it'll iterate over everything in A. And that's how it works, I guess. Oh, this one makes it the index. So this gives you the index, I guess. If you do it this way. So index 0 is Mary. Whereas up here, if you were doing it this way, your variable is being assigned the word. It doesn't tell you what index that word is. And I guess that's something you can be aware of when doing. Oh, why do they introduce sum here? So sum is another built-in function that just takes all the values that are passed to it, and usually it's an array or a list. So if I type range 10 here, it'll return this, and this is what it evaluates to, 0 to 10. And you can pass that to sum. And that'll give you all the numbers added up from 0 to 10 and give you 45. The way, one math trick to calculate this is the number you're going to times the number plus 1 divided by 2. So this is 110 divided by 2. Oh wait. So n is 10. Maybe it's minus 1. 10 times 10 is 100 plus 10 divided by 2. So that's 1. It's either 110 or 109 divided by 2. Oh no, it's divided by... Christ. What is that trick? In minus 1 over 2? Minus 1 over 2. This is for summing up to a number sequentially. This is a little equation that does that. I think this is it. So this is 10 times 10 is 100 minus 10 is 90 divided by 2. Yeah, okay. So it is n minus 1. So it's 100 minus 10 is 90 divided by 2. 45. Okay. So just to get that, I always get the whether it's the previous value. Really, this comes from a series. If you ever get into like, I think they introduce you to sequences and series in pre-calculus, or maybe that's early calculus. It might have actually been in calculus. So you have to, when you're thinking about how sums are represented with E, it's called a sigma notation. This is what they're doing. They're adding all the numbers. Did I not hit enter? So n times n minus 1 divided by 2. This is the equation. And I'll just hit enter on that. And if we set n equals 10, and then we run this equation again, int, what does this say? Int object is not callable. Oh, it thinks it's a function. I forgot where I was. So this is n times this. And with order of operations, I don't think I mentioned before, but we don't have like individual levels of orders of operation. It's not like PEMDAS, really. So if you were doing something like this, you would do parentheses first, then divide, or exponents, parentheses, exponents, multiplication, division. How that would work. If I had these the other way around, it would do the it would still do the multiplication first in PEMDAS, standard mathematical orders of operation. But in computers, they have tiers. They have several tiers. I think unary and exponentials go first. A unary operation is like -1. This is a unary operation for 2's complement, which is how you make a negative number in a computer. And apparently Python also has a positive unary, but all it does is return the right operand. It doesn't really do anything. So in normal math, this would still be evaluated, this parenthetical, then this multiplication, then this division, but multiplication and division in most computing languages have division and multiplication on the same tier. So it would do n minus 1, it would find that first, which is 9, and then it would divide, and then it would multiply. But that's not how you would expect it. So what would we expect this to do? It should be 9, and then you'd want it to multiply by 2, and then take n and divide it by that number. But that's not what happens. This is what I expect to happen. 10 divided by 9, so that's 1 point some odd number, 1.08 or something, or 1.1. Yeah, 1.1111 something. And then times 2, so we're looking for 2.2 or something is what I expect this to be. Yeah, 2.22222, repeating. But that's not what we wanted. We wanted it to multiply by this. So we wanted it to be 10 divided by 18. And that's what you see a lot of parentheticals in math operations on computers. So what I wanted was n times n minus 1 divided by 2. And this should be fine because the multiplication and division happen on the same order of operation in computing. And so if you have operators that do work on the same tier, it'll be evaluated from left to right. And so we get the 45 we're expecting. Okay. And they also introduced the list keyword. List keywords just take whatever is passed to them and creates a list out of it. So we can make a list. We could say x equals a list of 2a and a is not. A would have been treated like a variable, so you have to say the character a and 8.0. Make a list out of this and assign it to x. Oh, at most 1 argument. Weird. Well, it doesn't make a lot of sense to say like this. Anyway, here's a list. So usually you put in here things that generate lists, not actually a list, because it's already a list. Maybe a set, and we'll talk about sets later. But here they have range 10, or let's say 3, just to get 3 numbers. Now x is the list of numbers from 0 up to but not including 3. So I'm going to conclude this video. We went over for loops, and really there's a lot to talk about with looping and how we can use loops to manipulate information to get things the way we want them. Loops, you'll find, are very useful in algorithms, but usually the more loops you have, the worse your performance is, because it increases the number of operations exponentially, usually.